So again, we look at the array 1, 3, 6, 10, 15 and so on, 2, 5, 9, 14, etc., 4, 8, 13 and so on, 7, 12, etc., 11. Okay, now we will read it in a different way. We will read it diagonally. So we have 1 here, then 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14. So it's a very natural way to read it diagonally. If you have studied Cantor's diagonalization, this will almost come naturally to you. If you have not, you can look it up in the internet. Cantor's diagonalization. It's a very beautiful piece of mathematics. Okay, all right. Now what we will do is we will read diagonally and we will check in which diagonal 20096 is in. Instead of looking rows and columns, we will look at the diagonals and we'll check in which diagonal this particular number 20096 is in. So to do that, there will be two pieces of numbers. If it is in this particular column, then we will know that it comes after this number and before this number. Notice that the top numbers are simply the triangular numbers. So 1, 3, 6, 10, these numbers are simply the triangular numbers. That is the numbers of the form n into n plus 1 by 2. You can plug in n equals to 1 and check, n equals to 2 and check. You will get these numbers. If you plug in n equals to 1, you will get the first number. If you plug in n equals to 2, you will get the second number and so on. Okay. So the number 20096 is between two triangular numbers. The first triangular number is the first number of this particular diagonal, and the second triangular number is the end point of the next diagonal, and this number is between them. So suppose it is between the kth triangular number and k plus 1th triangular number. It could be equal to one of them actually. That's fine. So it's 20096 is between the kth triangular number, which is the kth diagonal, and then we have the k plus 1th diagonal. We're almost there. Just multiply by 2. If you multiply by 2, you will get k into k plus 1 is between 40192, 40192 and less than k plus 1 into k plus 2. Now you can try to find out k by actually constructing a quadratic. K into k plus 1 equals to 40192. You could do that and you will get a fractional, possibly you will get a fractional value of k and maybe reduce k by a little bit to the lower integer and you will get the value of k. That's fine. But you can also notice that if k plus 1 is 200, then k plus 1 is 201, then you will get 40,200, which is a little bit above 40192. So by inspection, you can also do this. If you take k plus 1 equals to 200, okay. So 40192, is between 200 times 201, which is 40,200. It's a little bit above this number. So clearly k into k plus 1 is 199 into 200. So this is the value of k. Okay, so this is the 199th diagonal. 199th. So, I mean, not this one, but the kth diagonal, I mean. So, this is the 199th diagonal. And this is the 200th diagonal. And the last number of the 199th diagonal is this quantity divided by 2. 199 times 200 divided by 2, which is 19,900. So the last number of this diagonal is 19,900. So you start here with 19,901 and you have to go up to 20,096. So you have to go up 196 steps. 196 steps. Notice that if each step you go up, you reduce the row number by 1. Every step you go up, you reduce the row number by 1 and you add the column number by 1. Right? If you go up by 196 steps, think about it. You go up by 196 steps along the diagonal, means you reduce the row numbers by 196 and you increase the column number by 196. Okay, so we are done. Now you can tell me in the comment exactly what is the row number and column number of 20,096. Can you give me the final answer in the comment? Is just one line. Thank you everyone, and I'll see you in the next video.